The topic I present here is basis of software estimation, which convey the idea about the development. In this, there are two levels of development. First one is the macro process, then the next one is the micro process. In the macro process, there are five phases. First one is conceptualization, analysis, design, evaluation, and maintenance. In conceptualization, the developer establishes the core requirements. Then the next one is analysis. In the analysis phase, develop a model of the desired behavior. The another one is the design phase. In the design phase, it create an overall architecture, that is the framework. Then the next one is the evaluation phase. It evaluates the implementation. Then final one is the maintenance. In the maintenance phase, manage post delivery evaluation. Then in the micro process, it identifies the classes and objects at a given level of abstraction. Then also identify the semantics of these classes and objects. Then identify the relationship among these classes and objects, and also specify the interface and then the implementation of these classes and objects. The microprocess represent the daily activities of individual developers. The macro process serves as the controlling framework of the microprocess. The basic philosophy of the macro process is that of incremental development. The system as a whole is built by step basis of software estimation. Software estimations are of utmost importance in software development lifecycle, where the time required to complete a particular task is estimated before a project begins. Estimation is the process of finding an estimate or approximation, which is a valuable that can be used for some purpose. Which is a value that can be used for some purpose, even if input may be incomplete, uncertain, or unstable. Basic steps in software project estimation. Estimate the size of the development product. Estimate the effort in person, month, or hours. Estimate the schedule in calendar month. Estimate the project cost in dollar or the local currency. Then the next one is shortcoming of SLOC measures, that contains no precise definition, difficult to estimate at start of project, only a code measure, programmer dependent, does not consider code. Complexity estimation is based on past data or past experience, available documents or knowledge, assumptions, identified risk. Then estimation need not be a one-time task in a project. It can take place during acquiring a project, planning the project, execution of the project. Project scope must be understood before the estimation process begins. It will be helpful to have historical project data. Project metrics can provide a historical perspective and valuable inputs for generation of quantitative estimates. Planning requires technical managers and the software teams to make an initial commitment, as it leads to responsibility and accountability. Past experience can aid greatly, that is, previous experience can be helpful for this. Use at least two estimation techniques to arrive at the estimates and reconcile the resulting values. General project estimation approach. The first step for this is understand the scope of the software to be built. Second one is generate an estimate of the project software size. To estimate the project for a software size, first start with the statement of the scope. Then decompose the software into functions. that can be estimated individually. Calculate the size of each function. Derive effort and cost estimate by applying the size values to your baseline productivity metrics. Step 3. Generate an estimate of the effort and cost. You can arrive at effort and cost estimates by breaking down a project into related software engineering activities. That is, break down the project into smaller modules. That is, identify the sequence of activities that need to be performed for the project to be completed. Divide the activities into tasks that can be measured. Estimate the effort required to complete each task. Combine effort estimates of task of activity to produce an estimate for the activity. Obtain the cost units for each activity from the database. Compute the total effort and cost for each activity. Combine each effort and cost estimate to produce the overall estimate. Reconcile estimate compares the resulting values from step 3 to those obtained from step 2. If both sets of estimates agree, then your numbers are highly reliable. Otherwise, if widely divergent estimates occur, conduct further investigation concern whether the scope of the project is not adequately understood or has been misinterpreted. The function and the activity breakdown is not accurate. Historical data used for the estimation technique is inappropriate for the application. Then the next step 5 is determine the cause of divergence and then reconcile the estimate. Estimation accuracy. Important factors that affect the accuracy of estimates. The accuracy of all the estimate input data. The accuracy of any estimate calculation. How closely the historical data or individual data used to calibrate the model matches the project you are estimating. The predictability of your organization's software development process. The stability of both the product requirement and the environment that supports the software engineering effort. Whether or not the actual price was carefully planned, monitored, and controlled, and no major surprise concern that cause unexpected delay. Some guidelines for achieving reliable estimates. Base estimates on similar projects that have already been completed. Use relatively simple decomposition techniques to generate project cost and effort estimates. Use one or more empirical estimation models for software cost and effort estimation. To ensure accuracy, you are always advised to generate using at least 2 techniques and compare the results. Estimation issues. Project managers resort to estimating, rescheduling, skipping, and estimate size. This may be because of the timeline set by the top management or the marketing team. Whatever the reason, if that is done, then at a later stage it would be difficult to estimate the schedule to accommodate the scope changes. While estimating, certain assumptions may be made. It is important to note all assumptions in the estimation sheet, as some still do not document assumptions in estimation sheet. Even good estimation have inherent estimations, risk and uncertainty, and yet they are often treated as though they are accurate. The best way of expressing estimates is a range of possible outcomes by saying, for example, some projects. Then beware of committing to a range that is too narrow, as that is equivalent to committing to a definite date. You could also include uncertainty as a accompanying probability value. Organizations do not collect accurate project data since the accuracy of the estimates depends on the historical data. That is, it would be an issue. For any project, there is a shortest possible schedule that will allow you to include record functionality and produce quality output. If there is a schedule constraint by management or client, you could negotiate on the scope and functionality to be delivered. Estimation guidelines. During estimation, ask other people's experience. Also, put your own experience at risk. Assume resources will be productive for only 80% of their time. Resources working on multiple projects take longer to complete tasks because of the time lost switching between them. Always built in contingency for problem solving, meeting, and other unexpected events. Allow enough time to do a proper project estimate. Use developer based estimates as estimates prepared by people other than those who will do the work will be less accurate. Reconcile the estimates. Observe the convergence or spread among the estimates. Convergence means that you have got a good estimate. Re-estimate the project several times throughout its life cycle. Thank you.